Question number 19. A simple pendulum oscillates with period t on Earth. The mass of the pendulum is doubled. Mass of the pendulum is 2 times m. 2 times m. And the oscillates on the moon where the acceleration due to gravity is 1/6 of the Earth. Acceleration due to gravity on moon is 1/6 of the Earth. GE divided by 6. Okay. The length of the pendulum stays the same. Okay. L is also same. What is the period of the pendulum on the moon? What is the period of the pendulum on the moon? Now we know that time period is given by the formula 2 pi into root of L by G over here. Is there a contribution for mass here? There is no mass coming here. So I need not worry about mass. Okay. So therefore, whether it is mass is doubled or tripled or whatever happens, nothing is going to change. So therefore, I will have this formula and I will write this is for the Earth. When I say for Earth, L is not changing, 2 pi is not changing, only G is changing. So I can write GE here. And T on moon should now be 2 pi into root of L by G moon over here. Now what do I need? Time period on pendulum on moon. So I will take Tm divided by Te. I'll take this as a subject. Should now be equal to square root of 2 pi root L. 2 pi root L goes on both the sides. So I will only get Gm by G because time period is inversely proportional to the acceleration due to gravity square root. So I will just write this as GE divided by GM, not GM by GE. I told you mistakenly. It is GE by GM. So what is GE by GM? You look at this here. GE by GM, GE by GM, GE by GM. From this expansion is equal to 6 over here, right? This 6 goes away and this GM comes downwards. So it is 6 over here. So I will write this as root 6. So T moon is equal to root 6 times T earth. So root 6 times T earth. Root 6 is T is nothing but T is T. So answer should be B.